All right, welcome to episode 3 of the so-called Metal Building Show. Today we're going to talk about reading plans, but my name is Eric Beavers. I'm the president of Great Western Building Systems.
My name is Jared Miller. I'm chief detailer here at Great Western Buildings.
I'm Aaron Cowdy. I am the yard manager at Great Western Buildings.
And I'm Justin. I'm the video production geek.
Right on. Thanks for joining me again, guys.
Yes, sir.
The last couple of weeks have been, I don't know, a little unscripted or a little, kind of unoutlined. We kind of just wung it. This week, not changing format, but we did put some time and made an outline so that we could stay a little bit more on task and keep things moving quite a bit. So one thing that, Aaron used to work in customer service. So, we get a lot of questions from people asking things that are already on the plan. So they have to, call in, kind of explain what they're looking for, and then in order for us to guide them to that place on the plan. So today, yep, exactly. So we're going to go step by step through the plans. We're going to hit basically every page. We have a basic job pulled up. It's got some cool features, nothing crazy, but really just part call outs, and dialing through that. So, when you're in the field, you don't have to stop and, make a phone call or really scratch your head. We'll just show you where that stuff is. I think the first thing though, we did get a comment or a comment on last week's episode. Trail 80 sent in a question. He says, "Hey, thanks for putting these videos together. Very interesting. Can we do an episode diving into maintenance and care of these structures and possible problems that may arise during ownership? Stuff that immediately comes to his mind is water intrusion, earth movement, fire, snow, hail, wind, rodent, pest control." I mean, we could make a whole episode about that. But I think we could just hit a couple of the big points.
Well, I've got one.
One what?
One issue that could come up, with building ownership.
Okay.
Just watch out for planes. Watch out for planes.
Definitely.
That's going to it's going to put a damper on your building, and you're going to want to get that taken care of.
Yeah, that voids the warranty.
Yes. Yeah. Yeah.
That'll buff out. So anybody, okay, so that is actually a customer sent that in. Some guy crashed his plane into his building, and he kind of outlined some stuff. So we're working on a repair for him. Yeah, don't. All right. Yeah. But Aaron, what do you think the biggest thing when it comes to maintaining a building after you get it put up?
I don't know, just keeping, dirt and stuff, and I don't know, anything you can off the base so it doesn't really sit there. Let things get piled up towards the base because the bottom of the sheeting could get rusted.
Piled up. You mean like grass clippings or like a pile of leaves or
dirt, anything like that,
Yeah.
Maybe go out and power wash it, down, not up.
Right. That is a probably the most critical thing. I mean, they're a pre-engineered metal building, right? Once they're put up, they should be basically maintenance free. But if you get, soil or a bunch of stuff that stays wet up against the panel, it can cause the paint to fail, and you can also get rust creepage from the bottom cut edge. So yeah, good call on that one.
And yeah, other than that, I don't know. I mean, they're pretty self-sustainable.
Right. Not like a pole barn where you're worried about tightening screws all the time.
Yeah, because exactly.
Right. Wind damage. Airplane damage, though. That's
I can't.
Yeah, you gotta watch out for those airplanes.
Right. And Jared, actually, we were just talking about it before the show. On the website is the maintenance thing.
Mm-hmm.
Yeah, and on there's a pretty extensive list of just I think things that you can go through and that will help with the building maintenance. Put that together a few years ago, actually. Helped some people out.
Let's see. Yeah.
I think
am I sharing that? Yeah, right here.
Yep.
Under resources and downloads.
Yep. Yeah, I was just going there.
Yep. Yeah.
I think
The maintenance guide. It's on the website, and we're actually going to be coming back to this page later. Oops, not that one, but the construction details. And I was going to make a video. Am I still sharing my screen here? Yeah. I was going to make a video about this.
it's under resources. Yeah, there it is.
In the very bottom.
Oh, 3D animated detail library.
Yep. Any of those will work.
Okay, we'll be coming back to this on the episode, but we got some really cool resources. So,
Yeah, that is really cool. I like that we have that on the website.
Mobile friendly too, which is nice if you're up on a ladder or a lift, or you only got one hand and a phone in it.
Yep, Justin
Nice.
did most of that animation for us. We've not done the trim details yet. It's a lot of work.
Yeah.
And some of the
How many of those are there? Like 1,000?
like 1,000.
Something like that.
And some of the descriptions really require me to write, or probably Aaron. And yeah, we've been busy, but the structural details are on there, and they're really, really cool and really, really helpful. So let's jump into reading the plans.
Yeah, let's do it.
Get to it.
You want to talk about the isometric drawing?
Yeah, not a lot of companies have this. This is, I think, a really nice part of the plans. You're able to look at it and kind of see what your building's going to look at. Like, when you even get, when you first purchase a building, you get this, and you kind of look out at your property and go, oh, well, I want it to sit this way or that way. I think it's a really nice cover sheet.
I was just going to say, and I think that one of the things that it really does too is obviously, kind of why we're doing this episode as well, is not a lot of people are familiar with reading these plans, right? But having that just mental image of this is like, well, I don't want the door there, or I want the window here, right? And this is a good way to just, hey, we need to like move that, and we don't have to teach you, everything that there is to know about a drawing. You can just kind of see this visually and like, yep, that's where I want that. No, it needs to be bigger, and that sort of a thing. So it really helps with speeding up the communication process too, which is one of the reasons why, obviously, as a company, we've elected to have this, show this.
Yeah, I agree. I mean, it's not normal. Most companies don't do it, or I can't think of anybody that does, but what we don't show cardinal directions on here, right? North, south, east, west. It's really not the way a pre-engineered metal building is done. It's not a site plan or anything, but it's really to give customers a quick, easy reference to the lay of the building. And if you look in the bottom right-hand corner here, we do reference the individual pages within the set of plans where this can be found. So, like sidewall framing and sheeting, right? So here's your frame line A. It's down here on 10 and 11. So it's easy to quickly get to the page that you want without thumbing through and making sure that you're looking at the right frame line.
So it kind of serves like a table of contents as well.
Yeah, I never even, I guess, realized that.
Yeah, I didn't know that until just now. I've just never used it.
But I just flipped through the pages.
Man, there we go. 2 people we've already helped learn how to use the drawings. Hey, this
really thought about already the drawing index right on there.
Yep.
Yeah, I just
this episode's already
helping. What I'm looking for when I look at that top page. That's awesome.
You're now a professional.
Yeah, that's right.
Yep,
that's what
I'm a pro now.
Yeah,
Heck yeah.
Congratulations, Aaron.
Yeah.
So one thing I'd like to kind of point out with most of the drawing sets here that we do as well is we also label on this this isometric, where's frame line 1 and frame line 4 in this scenario versus also like a frame line A and frame line E. That will help kind of dictate as you're going through the drawing set too of, wait, what wall am I looking at? You can, if you need to, you can kind of come back to this 3D of, oh, okay, I'm looking at this wall. So just in case you need it to, that kind of helps. It's one of the things that we add in there just to, once again, help clarify. And,
obviously we deleted the project information, but customer information, address, county, stuff like that is on there.
But that's a good point right there. Is your job number? If you do need to call in, that's the perfect place to find it, because it's happened a few times, and you got to look up last name. Sometimes it doesn't come up. So that
Right.
job number right under GWB.
Right. Or it's Miller or Johnson or Davis. And it's like,
Yeah.
holy smokes, there's 30 jobs. Yeah.
Yeah.
But Jared, you mentioned this the other day about the difference between permit and erection drawings.
Yes. Yeah. Yeah. The different just drawing types that we have. Yeah. Just back and forth. I mean, if you were to get a calling in, right, to customer service, or speaking to your PM or whoever, right, one of the main things that we want to make sure that we're talking about is in this upper right hand corner on all your drawing sheets is what version of drawings that you're on, right? So if you're calling in and you're looking at your permit set, well, we're looking at, you know, the final construction set or the erection set. So there may be differences just in that. Most of the time it's not much, but sometimes once you start getting to, you know, sometimes like the walls and stuff, piece marks start changing. Sometimes we're adding a little bit of clarification, maybe another detail or two.
Trim callouts.
Yeah.
Part numbers. So the difference between the permit set and the erection set, structurally, they're identical, right? The size of the members, their locations, all of that information is going to be the same. And really they're called permit plans because they're there to submit to the building authority for permit. They're good to pour foundations with. All of that information is correct. The anchor bolt pattern is not going to change. Typically, sometimes if it does, it happens so rarely, we're in detail. We'll come back to the customer and ask if he's poured, or she or whoever has poured those bolts, because we want to make a small change to it. That's so super rare. So the plans are good to start building off of, but the erection plan are after it's gone through detail. So I think a big thing that you'll see will change is like girth numbers, right? So there might be different girth numbers. It's the same part. It's shown on the drawing, but on the permit drawings, it might be shown as girth 18. And on the construction plans, it's actually shown as girth number 21. So it's important to do that. And all that corresponds to the shipping list. And then trim also. The trim table is always going to change.
Yes.
And a good way to know that they're permits is
there's a stamp on them.
Stamp on them.
Yep. Exactly.
I've had that conversation plenty of times. Like, is there a stamp on that? And they're like, yes. I'm like, oh, well, that would be your permit drawings. That's why we're talking two different things here.
And the erection drawings are what you want to use in the field when you're erecting the building. And we ship 2 sets of these with the building in the warehouse box, along with a clean shipper and everything. And a shipper is just a bill of material.
So this is the second page, right? You know, of the drawing set, what we call the building info cover sheet. You know, the top right hand corner, you know, is basically just your design loads, what we've designed the building to. You know, what we've worked with your maybe local municipality or you know state codes or whatever. That's all the information shown there. You know, design constraints and stuff that we used. Down below that box on the bottom right is where we'll start getting into more of the building information, you know, size, length, height, roof slopes, base spacings. Mainly the one thing that we're looking for here is colors and calling out types of panels and stuff. This is a really popular area to go and make sure that you know we've communicated all of that correctly. You know, there's times where some orders, you know, they need or want to change their color, you know, and if this is a good spot to make sure that we did adjust that and get it to what you're liking. So,
and if you get insulation through us, we'll also have that below the soffit panels and trims, which or if we designed it for you, we put what R value you need for your roof and wall.
Right. So if it's by us, it's the insulation is called out usually right in this area or below or somewhere else.
Yep.
If the building has a lean-to, those specific details will be called out next to it. And then if you are insulating but not using it through, not having us supply it, we'll still list the insulation requirements. Just right, not by Great Western Buildings. I was gonna say here, we have all of the the standard notes, and these notes here are, for reference while you're building the building. If there's a specific torque requirement on the A325 bolts, the structural bolts, that'll be shown here. Jared, you're mentioning 2.9?
That's
just talking about anchor bolts.
Right.
So yeah, we can jump into anchor bolts on like the next page if we.
1.6 might be a good one. Does that have the detail for turn of the nut method?
Yeah.
You can kind of show them where it calls out if you're a C or below, your seismic design category C or below, or with the crane system 10 tons or less, does not require turn of the nut.
Right.
It'll just be snug tight.
And there's different ways to pre-tension bolts. Most buildings, if you're in seismic zone D, you should pre-tension your bolts. Turn of the nut method is the easiest. It's also the least accurate. And we don't need to get into turn of the nut, but basically make a mark on the frame and on the bolt. Once it's snug tight, then you turn the bolt, X number of turns or a percentage of a turn, to pre-tension that bolt. Seismic C below without cranes, it's not necessary, and that's mentioned here. So sometimes people have a question from their building authority or the inspector, and you can just reference this thing here. If you are seismic zone D, it's something to think about. But like I said, there's a bunch of different ways to pre-tension bolts. You can do the Skidmore test. If you're going to do that, make sure that we know so that we can put everything, the heat lots, into the system and give you a couple of extra bolts that can be twisted to failure for the inspector. Usually the inspector's going to want that, but turn of the nut is the easiest. Everybody has the tools for it, and it's good enough.
Yep, just a cheater bar.
So moving on, third set or third drawing typically is the anchor bolt plan. This is really a coordination effort between the metal building and what we plan on doing versus the foundation and coordinating those efforts, right? We kind of last episode talked in depth about anchor bolts and what those are. And here's where we're essentially showing column placement, base spacing. In this particular example, we've got some field located framed openings. So basically what bay they're going to be in and how many they're going to be in. And once again, so this is just kind of the general layout. Like I said, almost a floor plan. But like I said, this one's called the anchor bolt plan, and it's calling out the anchor bolts, and we're in a kind of a generic reference, and we'll do that kind of with details, kind of be going back and forth between this page and the next page. They're really coordinating together. As you can see at the upper right, we call out an anchor bolt summary. We like it here on the anchor bolt plan. Some companies don't even give you one. They want you to go in and kind of do your own counts. We try to make that a little bit easier, especially when you're ordering all of this stuff, so that that you'll have what you need on site. The idea here is that we're trying to make this as quick and painless as possible for anybody to understand, and like I said, just coordinating those efforts between us and the foundation engineer.
There is a symbol for each bolt type. The 3/4 inch bolts have the X through the symbol. That doesn't mean that we're not using the bolt or it's not part of it. It's just an easy reference. So here, this building is going to need 8 5/8 inch bolts, 12 end wall bolts 3/4, and the frame bolts are the same. And you can see that. Let's go to framed opening here. Here you can see there's a, the circle without an
cool.
X, and then these have the X. So, you know exactly which bolts go. And of course, on the next page, the details, it's clarified a little bit more, but this is a good.
I didn't know that was indicated there. It's pretty cool.
One of the other things that we were kind of talking about last episode too, is whether or not to have a sheeting notch. This particular building and customer did not want one, so we typically don't show that on the plans. Obviously, if you did want one, you just need to let someone here know, and we'll be able to draw that sheeting notch on your plans.
Yeah. So real quick on that, standard, unless we are asked, we will not show the sheeting notch on this page details, or the detail page for the anchor bolt details. We will show an option for it in TD 74, whatever, in the actual building details. But if you want a sheeting notch and you want some clarity, it's easy for drafting to show that in all sets of drawings. This is really there so that there's fewer errors in placing bolts, and it's just a cleaner set of drawings, right? Aaron, you want to mention the grid lines here?
Yeah. You have, if you went all the way back to the front, you have your front sidewall, back sidewall, left end wall, right end wall. But our frame lines, we call out, and the frame lines are main frame lines, right? So on the right side of the page is frame line A, B, D, and E. And then on the left is A, C, and E. But the reason that we have a D and a B here is over on the left, they actually have a main support column, which is C. And also, just looking at that, when you're looking at front sidewall or your frame lines, they'll all be called out on each page, so you'll know what you're looking at.
Right. Like frame lines 2 and 3 here. Well, this is all rigid frames. So 1, 2, 3, and 4 are going to have rigid frames. I think they're all rigid frames. But you can reference these grid lines in other sets of plans. So then you can kind of get the lay of the land here. The other thing, I guess this is important for the next page, these call outs at each of the anchor bolt details or locations. We have detail A, we have detail B, another B, C, D, and that's all called out next to them. And that really corresponds to the following page, which is
everybody's favorite anchor bolts.
I call it the details, right? So detail A, detail B, details, these all correspond to these call outs here. Another thing that's worth mentioning, and on larger buildings, we'll get some questions on it. A lot of the plans are to scale, or parts of the building. There are specific things that are not to scale. Metal building drawings are generally printed 11 by 17. If these locations and these door frames or jams and the anchor bolt details here were actually shown to scale, you wouldn't be able to read them. They would be too small.
It looks like dots on a page. And it's like, well, what's that? Like, well, that's what it looks like.
Right. So it looks like these jams and these layouts are 3 or 4 feet. It's a little bit more, a little bit more obvious that it's not to scale when you're looking at a bigger building. So, but yeah. All right.
Some of the details are slightly off too on purpose, just to make it a little more clear what you're looking at.
Yes. Yeah. We between the anchor bolt plan and the anchor bolt details, they're exaggerated on purpose, right? We're trying to, really zoom in and make this exaggerated for clarity. Sometimes if we were to draw some of the stuff, to scale, once again, it comes across really tiny and hard to read. And then there's even more phone calls. So, speaking of, the details, right? If we were to just we'll look at that detail A. As Eric mentioned, it's on the left end wall, which is at grid line 1 and grid line C, right? And that's where that's at in this set of plans, right? And that detail, if we were to kind of go to that, once again, it shows you what diameter you need for that column that we have there, and then it also shows you how deep and how big that column is going to be. So this particular column is only 8 inches deep, and the plate that we're using is 6 inches wide, and then that solid line that we've got through there is you'll hear us call it out a lot, as steel line, and this one's referenced as the end wall steel line, right? Which is why we have the EW there. EW stands for end wall, SW stands for sidewall, and another one that you might see pretty common is CW, which stands for common wall, which we do not have in this set of plans.
Common wall would be 2 buildings adjoining, like a lean-to or yep.
Correct. So there we have, if we're still looking at that grid line A, that's we're pulling the dimensions off of,
not grid line, detail.
Not grid line A. I'm sorry, detail A, off of grid line 1, but you'll come off of that steel line end wall by 2 inches. And then your next set of bolts will be at 4 inches in. And then we're measuring to the center line of the beam, and then we go in each direction an 1.5 inches. So that's how we're locating, detail A. We generally try to do a good job of reflecting exactly how the detail A is in correlation with the drawings, but sometimes we can share details. So for example, if we skip to detail C, right, it's down here at the bottom left, which is grid line 1 and A, and that's the one that we're depicting in the plan or in the details, but it's actually off of grid line E and grid line 1 as well. So it's just mirrored. But it's the same anchor bolt pattern, the same layout, and you're just going to be coming off the corner in those same directions as the dimensions tell you there. And we try to, once again, we'll label it which one's the sidewall and which one's the end wall, so that you're not getting turned around or anything like that when you're actually laying these out in the field.
Right. And that's why it's important to know to get your lay of the land, end wall and sidewall. Because this one, besides just being flipped up, it's also, I guess it would just be flipped up, but you could think about it being rotated also, depending on which way you're in your head, you're going around the building. So these grid lines here, what I would call steel line or the end wall line, the sidewall line, those are generally, when you're looking at it on the page, the way it's laid out is the way you'd be looking at it face down from the outside of the building. So this is basically the line between, I don't have a detail for it here, but where the panel would meet the building, right? That's the out to out dimension of the building, is the end wall and the sidewall.
We might touch on detail F. Let's talk about detail F just for a second, right? So when we're looking at the detail, right? If you're looking at the plan view of this, we're talking about door jambs on this one. You go to the face of the C, and then you're measuring back the 1 3/4 for the anchor bolt holes, right? So that C plan dimension there, right? If we're to scroll back up, right? So if we're looking at like grid line, the one at 1 and A, that F dimension is 4 foot to the C, and then back 1 3/4 for the actual location of the anchor bolts.
Right. So we're measuring 4 foot to this line, which gets from the edge of slab or whatever steel line. And then, so that gets us here, 4 foot. This one's mirrored. And then the 1 3/4 you're talking about is actual center line of the bolt. Yep. And that's an important measurement and something that I've personally messed up in the field is forgetting when I'm looking at the detail, especially if the concrete's not been sloped, that door jamb is mirrored and I'll accidentally measure 1 3/4 the wrong way. So it's good to mark the actual, if you're drilling these things, you could just take a speed square and draw a line. And Aaron, I think you prefer drilling these types of bolts, right?
I do. Yeah. Just because once you get the building racked, you could have that 14-foot dimension as soon as you get it plumbed up and racked, and then your jams are off and you got to slot holes or re-drill holes or, however it goes. And yeah, I mean, it's pretty, I don't know, it's 4 foot to that. Oops. And then you could go 14, you could go the whole 14 foot and put the other jam there. But when detail F says, they say C plan on frame line C, it's showing you just go from center of that 2 foot over, and which is probably a lot better measurement than trying to pull your tape 14 foot and make a mark.
I like to do it both ways.
I like to check it that way.
Yeah, back check it. Yeah, exactly. And I always took the speed square, laid it down on the slab, and then would use a Sharpie to mark my jam as well, just for keeping my head straight.
Yeah, I think it's
I would
really
use a
important.
pencil, not a Sharpie.
Yeah, it's really important too, because I mean, once you're walking around the foundation, several times and going from corner to corner and pulling different measurements, right? It's pretty easy to get turned around in the building quite quickly, especially when you're just looking at a dirt floor with with a whole bunch of rebar and stuff out of it.
Right. I'll hit on the anchor bolt projection real quick. So the metal building company, Great Western, whoever, we're not going to define the depth of the bolt. We're going to call out the grade that's mentioned in it's just A307 machine bolt, A36, F1554. There's different call outs for them, but basically any standard all thread or whatever you're using for a bolt, it's not a special hardened steel or anything, but the projection is called out in this table here. So how far we want that bolt to stick up out of the concrete. And that's really what we're going to call out. Depth is a foundation design, which we talked about last week. And so that information is there. So like on this building, 5/8 3/4 standard, it's on, every building. Sometimes you'll see 7/8 or 1 inch, but a 5-inch bolt is going to stick out 2 inches and a 3/4 inch bolt is going to stick out 2.5. And that's to make sure that there's enough clearance to get the nut on completely threaded, and snug up against the plate. Reactions. Yeah, I'll hit this real quick. This is just the math, guys, for the foundation engineer to use, right? So the ultimate reactions, what that anchor bolt and the concrete underneath that anchor bolt needs to resist is called out here. It's no erector's actually going to, use anything here. This is a structural calculation, so we can skip over that.
Yeah, I was like, I don't know.
That answers like all of my questions. Yeah.
Right.
Never looked at anything on that page.
For customers that, are bringing in an outside engineer that's not familiar with pre-engineered metal buildings, either myself, Raj, Dan, Richard, we can guide people through, foundation engineers through this. So, and it's not because they don't know what they're doing. They're just trying to make sure that they're understanding the ultimate numbers correctly and not missing anything. So just if somebody's doing it, call. It's simple.
So the next page that we got going on is the where we start getting into the fun stuff, the actual building portion, right? The rigid frames. So we're looking at that first rigid frame on frame line 1, which was our left end wall, right? We're looking at that frame there, and that's what this first one is. Yep. right there. So from that isometric, that's what's on page 6 is that first frame. So this is where, you get to see how tall your building is, kind of what's going on inside, how we plan on framing it out. I think most people here what they're, as a customer, what you'd really be looking for, would be clearances, right? If you've got, I would be looking at the clearances if I were a customer. I think that that's the main thing that you really need to focus on, with this portion, because that's going to, if you've got like we've got a low side clearance at 16.5 and 7/8, if you've got a 18-foot, piece of equipment that you're trying to bring in here, that's not going to work. So this is kind of where we're telling you what we've got and what we plan on doing.
And here's that column for detail A,
Yep.
frame line C, which is called out here, so it's easy to see.
Yep. Once again, we always try to label all the grids on every single drawing, right? To once again help coordinate, as we're moving through the plans. It's basically, think of the grids, grid line A, frame line A. It's a coordinate system that we can use on a building to quickly identify where we need to go and where we need to be.
Yeah. Another obviously big thing when you're putting this up, your part numbers are on, the right side and the left side. Frame line E is an RF1-1. That's the column you're going to want to be looking for. If you follow that column up, you're going to see this SP1, and that's going to be in the splice bolt table to the left. And that's going to tell you what bolt you need to be using to make that connection from RF1-1, your column, to RF1-2, your rafter. And then as you keep going up, you'll see another SP1, same bolts are used. But I'm sure it calls out EC1. That doesn't have a splice plate, but if you look at center column EC1 up on cap plate bolts, it tells you also what the bolt is, and it's actually different. It's only 1.5 inches in length instead of 1 3/4 inches, and that being because the haunch connections are bigger for the rafter and column connections.
I'm trying to highlight this stuff while you're going, but it's a PDF, so it's a little clunky. And
Yeah.
Aaron, you bring up that. I mean, that's a great point, right? Because we wind up, people from jobs will call it, and it's a pain. We always just send extra bolts, because it's easier to just send extra bolts or go buy extra bolts or something than it is to go and remove bolts. So if you use up all of your 1 3/4 inch bolts by putting them in here, in other places of the building, and then you're, tying in something else, you might not have a bolt that's long enough because you used the wrong bolt somewhere else.
Yep.
Right. And
That happens. I've done it.
Yeah. A customer once asked me one time, I've been asked before, why don't you just send all the bolts out to the maximum length? And I mean, on a 5/8, I guess that's fine, but you can run into clearance issues, right? Like, so if you send too long of a bolt, on a pitched building, you might not have the clearance to actually get the nut and stuff in there. The other thing, which is more important on like 3/4, 7/8, 1 inch, 1 1/4 inch bolts, it becomes a really big issue, is the cost of those bolts. I mean, the difference in cost between a 1 inch that's, 2.5 inches long and a 1 inch that's, 3.5 inches long is like $5. And not to be the cheap metal building business owner cutting costs and stuff, kind of a jerk. Those would be costs that we'd have to pass on to the customer, right? So it would increase the cost of the building system. So that's why we try to make the bolts exactly what they need to be, just to save everybody money. And the customers, most importantly, right? If you want, if a customer wants 3-inch long bolts for every connection for ease, no problem. We'll quote it for you. But it's probably not worth the extra few $100, or maybe it is. I don't know. Depends on the customer. What else do we got here? Actually real quick. So there are other frame lines here. Rigid frames, frame line 2, frame line 3.
Yep, definitely.
And frame line 4. And on some buildings, like if it's like a 50 by 100 and every frame in the middle is identical, it would be, we would show frame line 2, 3, 4, and 5 all in the same page. On this particular building, they're all broken up because each frame is unique. And here's a good point that you were just bringing up, Aaron. Two different splices here. So splice 2, splice 1 for this 1 3/4 inch bolts here, 2 inch bolts here.
Yeah, you're getting into those bigger frames, right? So those haunch connections are going to be thicker. So it is important to go through and kind of lay that stuff out while you're putting this building up. Get all your bags together and figure out where everything's going.
And this shows SP2 and SP1.
Do you want to hit on flange braces?
Yeah, go for it.
Yeah.
That's a good one.
So up in the left corner here, over right below the splice bolt table, it's it says, well, actually it's, try to look at that. Maybe it doesn't say it here. Maybe it says it actually in the detail. But anyways, when you're looking at these flange braces, it tells you what flange brace you need and where it needs to go. But also there's a number next to it. Now we have, I think we've touched on this before. We have connections on both sides for your flange brace at the bottom of the rafter. But that's only just to make it simple. If you get things flipped around, but if it just says a 1, then it just goes on one side. If it says 2, then it goes on both sides of the rafter. I'm pretty sure there's a place somewhere where it says that, unless otherwise noted.
Right. While we're doing that, I don't know if it's going to change my screen, but I'm going to pull up the animation. Jared, what detail would that be?
SD51.
That's interior bay Purlin framing. So let's do SD50.
50. Sorry. Yeah.
Yeah, that one's fully broke out.
Yeah, so we do have these 3D animations, which you can go into, go to our website and actually pull these animations up. And these are also in the, am I sharing the screen?
You are.
Okay.
Yeah.
And it's also shown in plan view on in the details of the drawings, but where did that go? There was a better one here. Let's look at this one. I really like the way you did these ones, Justin.
Thanks.
And let me see if I can move this.
So that's a good example is like those bolts, stuff on that page is not perfectly to scale, but that's on purpose. That helps it be a better visual tool.
Right. And so here you can see the flange brace coming up, and it gives you a 3D visual of how that's installed. If I go, let's see this one. Man, you got a bunch of them here. Taking a second to load. So bypass Purlin, and this would be 2 flange braces, which I'll go back to the drawing. So Aaron, you can explain the parenthetical.
And you can also click and move around those with just the left mouse button, and then you can zoom with the scroll. So you can really actually, if something seems really confusing and it's kind of buried in the angle that you're looking at, you can change the angle.
Yeah,
I know some of them are kind of complex.
What's kind of crazy is it almost works better on mobile.
It does,
which is
really
so cool. So, I mean, it's so useful when you're at a job site, because you don't have a computer, and sometimes using a phone or a tablet, trying to do stuff like that. But it's so intuitive. It's really, really awesome. But anyways, that's what Aaron was explaining here with the flange braces. Real quick, Aaron, before the parenthetical, FB 37.8. If for some reason your labels are lost or you don't know what it is, that means it's 37.75 inches or 37 3/4 of an inches. Our system doesn't show, our labeling doesn't allow for the second decimal point. So, and Jared, does that measurement hold a hole or is that overall length?
It's overall length.
Okay. Oh, then that's real easy. So if you're not sure what something is, you can throw a tape measure on it and measure it out. And just remember that we're always rounding up on that point, on the decimal.
One thing that we could touch on real quick,
Yeah.
on the sheeting, you see the 3.5 inch mark there is telling you the overhang when you go to roof, and that's going to be from steel line. I get that question a lot. Is how much do I overhang this thing? Well, we have it in two places. We have it on your frame lines, and then we also have it in the detail. But that's not 3.5 inches. This has a overhang, but it's 3.5 inches from steel line.
This detail is different. This detail showing, oh, sorry. Okay. That's for the lean-to. I got you. Or the thing. So here,
exactly.
Detail TD26. Oh, so a lot of the trim details, and these are shown, but they're just in different sets of the drawings. We'll get to that in the elevations.
Yeah.
But back up on the rigid frame, but it's SD115.
Yeah.
Is called out. Yeah, and that's just the Purlin to the anti-roll clip connection. We can get into bypass and stuff when we get to the roof framing plan, and we are going to run long here, guys. We're already at
50 minutes.
50 minutes, so no worries. But here, that detail SD15 is called out in the circle, and it's showing where that connection is. There's details get a little bit more clear in the elevation drawings, right? Really, this rigid frame drawing is really to show you the assembly of the rigid frame, not the roof and not the walls. But there's another thing that we see here. This building has the flush Purlin system, or a flush girth system. Yep.
So what that means is just, for those that don't know, it just means that the girth is flush with the face of the column and at steel line. Whereas like in looking at this example, we normally try to bypass the Purlin out of, from the frame. It's a little less work on us and it's a little stronger. The engineers like seeing that more of the bypass.
The building a little bit lighter to bypass it.
Yep. But this particular one, I think that they were going to do like a interior frame out. So they were going to try to hide some of these columns, which is why they went with the flush girth system. And that's where, that's what that kind of means, is showing the girth at the steel line along with the column at the steel line as well.
Right. And a lot of people think that we're actually moving the girth in. I think that's the wrong way to think about it.
It's not more of moving the column out.
Exactly, because we're holding the out to out of steel. So it doesn't really save any square footage in the building to go with a flush girth. What it does is it just pushes your columns out and gives you an extra 8 inches or whatever the girth depth is, 8, 10, or 12 clearance inside of that frame.
Which is stronger?
Bypass. Well, I mean, both are just as strong.
You get a lap.
Yeah, both are just as strong once it's through engineering. Bypass is going to be lighter. So a flush girth system is going to be more expensive because the weak access on the frames needs to be beefed up, right? Because those like the Purlins here, we'll see the difference. We get into the details, but that lapping is super strong. And here they can't be lapped because they're not running through the center of the web of the column. Also, just real quick, if you're wondering, and this is important, if like there's a repair or something like an airplane lands on your building, these parts are shown, what the outside flange is, exactly what it is, what the inside flange is, webs, dimensions of those. And then of course, something we didn't touch on is the grade of steel is up here in the materials table. So that's not going to help you erect the building. So we'll skip it and go to, Aaron, you were talking about the parenthetical up here. The one call out. rather than 2. This is
one call out.
yeah,
Yeah.
exactly.
Yeah. And it tells you, I guess I thought it said something else, but up in the left corner, it tells you number 1 means one side, number 2 means 2 sides. So it is there.
And it does not matter which side you put it on. Well, obviously,
Yeah.
frame line 1, you can only put it on one side.
Right. When I put the buildings up, I would do one on one side, and then as soon as I got to the peak, I'd do it on the other side. But
You
it's
alternate them.
yeah,
Okay.
yeah,
Some
just
people
one
like that.
side of the rafter. Yeah,
So
and
it does
it's
not
up to the customer, you know.
exactly. It doesn't matter which side. It's really a preference thing.
Real quick, Eric, let me share my screen, and I will. So one of the other things I kind of created this, just as we're kind of going through it, 2 other things that you might find on the rigid frames.
Oh, okay, yeah.
Is if you have the first box here that I've kind of got in blue, is you might have an alternate member table in your drawing set. What that basically means is, at this frame line 2, we've got RF2-1, and then I've got that little A call out there, which basically says that at frame line 3, we have an RF2-5. Now that could be an additional stiffener is there, or an additional clip for whatever reason, but that's just trying to tell you that it's basically the same thing. There's just some small minor, probably shop difference.
We can also see the Purlin depth, but that's not important. Let's keep this going. Aaron, can you do the elevation real quick? I'm bringing it up. There you go. So frame line A.
Right. And to the top of your eave is going to be 18 foot. Between the rest of that, it shows you all of your girth spacings. So that could help you determining what you're wanting to do with the building. If you want to, add steel studs and do drywall, or liner, PBR panel on the inside. Then it gives you some more elevation as clearance goes. This has a portal frame, and so bottom of portal frame to top of slab is going to be 1511 3/4. On the very far right side on frame line 4, where this is still 18 foot, but it's giving you measurements to the bottom of your canopy here, which
Right, because there's a wraparound canopy on this building, isn't there?
Yeah.
Yeah,
So
on both walls. That is so awesome.
and with the wraparound canopy, I don't know how we can go over. Actually, we're going to go over a lot of stuff on this page, but one thing I always find customers asking is like, how am I attaching the wall sheeting above the canopy? Well, if you look on girth 13, it calls out an SA1, which is sheeting angle 1. So you're going to attach that to the girth, and then when you go to sheet it, that'll act as your base channel.
And Garrett, is
Base angle.
Is SD 104 the detail for that? It's basically a
No,
wainscot,
I think so,
right?
Yeah,
no, I think that that one, the SD104, is just showing how the framed opening sill goes together. It's up.
Right. Oh, the actually what I'm looking for would be shown on the sheeting side of the same page, which there's not a call out, but we can get to it.
It's going to be TD208 would be that detail.
Here we go.
Yeah, see, it calls out that sheeting angle that's going to be screwed to the top of the girth, and then the 2-inch side will be screwed down, and the 4-inch side will stand straight up.
Right. So what we're showing here is lower panel is connecting to the bottom flange of the flush girth, and then in order to connect the top panel, that's why that sheeting angle is called out there. Good. Nice point. Like if you go to the details, pretty much, questions are going to be answered in the details. So
Most definitely.
And if it's super confusing and you just can't figure it out, you can call us.
Right.
It happens.
Member table is called out here, which I don't think we really need to go over because we've gone over it and other things, but the girth call outs, you know exactly what they are. The gauge is called out. But I was thinking, most important that you're pulling off of this page is where your girths are going. So we have a G9 here, a G10, then we're following up with another couple of G9s, and over here 11, 12, and another 11 or whatever. And this girth is called out differently than girth number 11, even though it's probably the same length. Was that 11 and 12?
Hole punching.
It's hole punching. So that girth is actually unique. So we need to make sure that we're using a 12 there because it has the holes punched in it for this field located framed opening. And I don't know if that one's actually field located or not. It's not.
It is. It's up at the
I
top.
don't think
It doesn't. It does.
it is.
Yep.
Yep.
So what and field located framed opening is called out with that FLFO designation, and basically what that means is that the girths have not been pre-cut. So this is adjustable in the field. So, you know, a little bit adjustable, right? Like trying to change the RO of the opening is a little bit more difficult, but basically this field located framed opening can be put anywhere along this wall or another wall. It's really so you can make it, if an audible needs to be made in the field, it can be done, and we don't cut sheeting in a field located framed opening, and we don't cut the girth. So if it needs to be adjusted a few inches, you have that flexibility.
And one of the other things that I think that a field located framed opening does too is that it should still remain in the same bay, you know, because that's one of the things that we can see, like in that first bay, that first framed opening there, is that G10 is actually thicker. So we shouldn't move that to the second bay, right? Because it hasn't been accounted for in the design, but it can move from left to right anywhere in that bay, like Eric was saying.
Yeah, good point.
I didn't know that. So the G10 is actually thicker than the top one.
Yeah, because the G10 is carrying the wind load of that door.
Yeah, like
because G9 is split.
Correct.
So that's a 14 gauge versus a 9 gauge, and over here the G12 I think is
same thing.
12 gauge.
It's a 12 gauge, yeah. So it's even heavier.
Yep.
Good call out.
Which is probably for I would assume because the windows are sitting up there so it doesn't sag so much.
Correct.
But I don't know.
Here we have SD49 and SD150, which is showing us, I guess SD49 is showing us the girth connection, but SD150 is the portal frame connection, Jared. Is
Correct.
that right?
Yes. Yep.
Okay.
Yep.
And this is a nested portal frame. I don't think we have the time to go over all of that, but it does tell you where to find the detail on how to attach that portal frame to the building rigid frames. Again, part callouts, right? So on this line, you have your eave extension beam number 8. I think a better place to view this stuff is on the roof framing plan.
Yeah, sometimes we're calling out part marks on different plans to help people more coordinate of like going from one drawing to another. And that's kind of where some of that is and where that's coming from. So yeah, that EB8 is really more of an orientation mark than it would be what's going on there, if that makes sense.
Back to kind of the trim table type stuff. Here we have these square boxes with the number 1, a number 2, 3, 4, 5, 6. Yeah, 3, 4, 5, and 6 in these square designations. So these square boxes you can look over. Sorry. Here in the connection plates detail. So anything with the number 1 inside of that square box is telling us to use the CL100 clip. So that is a bolted clip. Sometimes it's just got to be. And it's telling you what clip to use there. And it can be easy. So a lot of clips are very similar. Like I think there's a big difference between a CL103 and a CL100, but there are, I have had times, in fact, in the Floresta video, I had to take apart a whole bay of door framing because I wasn't paying enough attention. I'm like, man, this really isn't fitting right. What's going on? And I go back and look, oh my gosh. So, that's what that is. And then the same deal here. Aaron, I'll let you do this one with the trim callouts.
Okay. So it's essentially the same thing as calling it. It's just part numbers. The difference with the difference between these is pretty significant because it has a detail with it. So this one on the you're over on the right, that works. That top window, calls out a number 4 on top, a number 5 on the bottom, and then 2 3s on the side. If you go up to here, you look at 4, it's, an FL52, which is a header piece of trim, but then it calls out TD52, and so does, 3 is 51, and then 50 is 52. So it's going to show you how to put this trim together for window, door, and pretty much everything on it when it comes to trim. And that's what I love about these plans so much, is they're very easy to read as that goes.
Yeah. So the detail would just clutter up the drawings too much if here we were to put another circle and a detail call out. So the detail call out, what to reference in the details, is up here in the trim table. Yeah, nice. And
there's a lot of trim.
There's, yep.
So it can be tedious.
Yep. And it tells you the length of the trim that should be in the trim box so that you can measure it and make sure that you're using it. So like here, the corner trim is called out with the number 2. That's our FL10 trim. And there's a corresponding detail.
And it tells you quantity as well. How many pieces of that trim that you're actually going to need. So, like in this one, we're looking at, that ID2, the corner trim, that FL10, there's 2 pieces. Well, it's 1 at each corner, 1 on the left, 1 on the right. Whereas like looking at the base trim, we've got 7 pieces of that, which is ID number 1. So you're going to need 7 sticks of that, helping kind of lay that out. So once again, it kind of...
And that is not for the entire building. That is just the section of building that you're looking at on this page.
Just that wall. Because if you go to frame line E, FL48, ID3 is 16 pieces, and that's going to be because there's so many more openings, obviously.
Right. Yeah. The jam trim. Yeah. And that was shown in 52. Let's skip over. Let's skip over this. We're eating up time. Let's jump into the roof plan. I think there's a lot to be pulled off of this.
Yes.
Wait, Jared, you wanted to look at detail SD202.
Yeah. Can you pull that up?
And
so on the
cable bracing on a flush wall. Yeah. Let's hit that.
Yep. So one of the things that Great Western does is that when we do have flush walls, and we'll have if the engineer requires like X bracing in that wall, we give a field work table. This is generally found on the end walls, but if you had like flush side walls, you'd have this too, where we coordinate and kind of tell you exactly where you need to drill slots to feed the cable or rod bracing through those girths, and how that's done. Eric, I think in your fluorescent video, you kind of show how that's kind of done.
Yeah. So, I mean, the reason why we did this, I don't know anybody else that does it, is because when I was erecting, I hated stringing cable, the cable brace or a string line, and then having to get up into a lift and figure out those holes. And you just do lower quality work when you're up in the air, I think. And so it's really nice to be able to do this on the ground. And I
think it's a great detail. I mean, when you were doing that, I was like, what are you reading on those plans? And you're like, I'm cutting them out. And I was like, how are you cutting them out? You got to put them up. And you're like, no, it's on the plans.
Yeah.
It was relatively new.
Jared, can you pull up a sidewall or an end wall elevation that would have that?
I was hoping it would be on this one, but it's not.
It's not, because it's rigid frames and there's no X bracing except for
the frames. Yeah, they don't want to.
That's kind of where I've got that, showing that table. Yeah, if you'll give me a minute, I gotta kind of hunt
We
this down.
just tell everybody, it's on if there's X bracing and it's a flush skirt condition, there's a field work table called out, and you can do that. It just makes it so easy. You just measure from the end of the girt, mark your holes, cut it, then fly the girt.
Yeah, and I do have to say this: when it's circled and it's 2, doesn't mean it's 2 girts. It does mean that it's the number 2 table. I've had someone do that.
Yeah.
So here's a totally different building, but this is kind of what
perfect.
we're talking about is, we've got this X bracing going through these girths here. So you've got, the 1 call out, the 2 call out, and then the 3 call out. And then over here in the field work table, we tell you exactly, hey, coming from if you go back to that SD 202, right? It
Pretty much just going left.
Tells you the dimension. Just, hey, measure from the left of the girt. Here's dimension 1. Here's dimension 2. But
right, and we're always looking at it the way we're reading a set of plans from the outside, looking at that girt, measuring left to right from the outside wall. Wow. So, yeah, pretty cool. And to the next question that I think anybody would have, actually, Slasher's Horror Cult, thanks for the comment. Appreciate it. The question I get from customers sometimes is, hey, why don't you just make those holes, your machine? There's not a center punch for it that's going to be that big. The machine's, the automation just really doesn't do it. So if we were going to do it, we'd have to, do it manually and just, cost more. And also, just in case you have an anchor bolt issue or that's not going to line up, which you'd be able to figure out in the field, the holes there, it's going to be there. So we only want to put in, as few holes as possible.
Well, and it also helps coordinating too. If you've got 3, G1s in that bay and we started putting holes in it, now you've got to go and find where that specific one went.
Yes, because then we'd have or we'd have to change the plans and have a G13A, G1 or G3B, G3, or a bunch of additional.
It's a lot.
Yeah, it is. Okay.
Are there any other companies that show where that X brace, like where you actually drill, or is it just us?
I've never seen it before.
I've never seen it, and I've put up a lot.
No. And it's a hand calculation that's done in detailing, so it's it's a little bit tedious, but I think it's worth it. On our end.
If I was the end customer, I would definitely want a professional doing as many calculations as I can get them to do for my money, as opposed to me having to do them in the field. I'd always rather put that onus on somebody who does that for a living, who I'm paying.
Absolutely.
Let's see.
Eric, real quick.
Go.
Do you want to go over B, C, and BA?
Yeah.
Calling out just because it's kind of the same on the roof too, right? So we could kind of go over that, but so there's a couple reasons that people have base channel. Maybe you have a Skyliner system, or you, like we were talking about, studding it up and doing, drywall, plywood, or if you just do a PBR liner panel, we call it out as a base channel. But if you don't need any of that, we call it a BA, which is just a base angle. That's just something that you might want to look at before, because on the roof it's going to be a little bit different too.
Yeah. And here I pulled up the detail. So this is a base channel. Okay. That's what BC means, and it shows that connection. So if you're doing an interior finish, you need a leg on the inside. If the building's not going to be finished on the inside, doesn't have that, then you just need a base angle. There's no reason to buy this extra material. Good call. Oh, here we're showing the sheeting notch here too. So this building,
look at that.
Yep. So this is if you're doing a sheeting notch. This is if you're not doing a sheeting notch. It's pretty clear on how it's called out. Back to can we jump on the roof now?
Yeah.
So this is obviously the roof plan, right? We've kind of got it separated, in this particular example. Not only do we have even rick extensions on the building itself, but we also have that 8-foot canopy on both side walls and the right end wall. So we've kind of pulled it apart from the building just to help, once again, exaggerating and clarifying that, really where the piece marks are, right? So this is a really good plan to look at as well, as far as, especially like when you're laying a building out, when you first get there, of, where does each column go? Where does my rafter go? And we coordinate a lot of those piece marks on these plans to help, showcase you where a lot of the bigger, heavier members are in the building. Along with obviously like the roof X bracing, that's there as well. We also tell you how to, with these eave extensions and the canopies, how to connect those, what size bolts you're using. We kind of talked about that, like on the rigid frame drawing, it was called SP, but here we kind of just showcase, like that EB6, right, which is right there at the corner. We're just going to use 4 5/8, 1.5-inch bolts.
Sorry, EB6 here.
Yep.
EB6 here. That's the overhang, not the canopy.
Yep, that's correct. That's
And
your extension, for your eave extension, and then your canopy, which would obviously be below it, is that EB9. Looks like you're using 8 5/8 by 1.75-inch bolts to bolt that to the framing there.
Right. And there is a structural detail for that. What was I going to say? Oh, so just back to the parts, each one of these, the EB3, the EB6, EB3 and EB6, they're basically the same length. They're here. EB4 and EB6 are the same length, but they're mirrored parts. So it's important. They are unique. So it's important to make sure that you're using the EB3 or whatever part in the correct place.
Yes,
otherwise you're going to be taking it off later.
Yep. Don't switch part marks around. If that's where we're showing you where it's at, I would put that one there. There's something different about it.
Cables.
Yeah. Hit the cables.
Luckily, there's not a lot of cables on here, right? But yeah, I mean, sometimes you have CB1 all the way to CB8, so it could get really convoluted. But like he has highlighted right here, we call out CB1, we tell you what length that is, and that's going to be end of.
That's overall length
to end of cable. Overall length.
From end of bolt to end of bolt, yeah.
Yeah, if for some, and it happens a lot because they're just they'll come off and you'll be like, well, I don't know what cable's what. Well, unfortunately, I'll have to
the part
take
tag
out a tape. Yep, and kind of look at that. Wish we had rods, cable rods, since we, they have to be connected,
with the coupler.
If you have a 25-foot, like if this was a rod.
That's for a different episode.
Cool.
Right. Yeah. Rods are only maximum of 20 feet, but this is 29'7". This is a cable brace. That thing's going to come complete with if it was a rod, it'd be called out as a rod, and you would wind up with one that's 20 foot and then one that's 9'7". And there would be a coupler supplied with it. So that's just the length of the rod that we receive here at the factory. So we have to splice those, and you really don't want to be messing with a 30-foot long 1/2-inch rod. You're gonna bend it. It's gonna get all janky just moving it around. I think the biggest thing that we're seeing here, the most important when we have questions from customers, is the overlap on the Purlins. So real quick, just on the Purlins, just like the girth page, we have P1s, P3s, P2s in the center bay. These are all P2s because they're symmetrical. Here we have P1s here, P1s here. They're symmetrical on those sides of the building. And shown in the member table. So the P2s are 16 gauge and the P1s and P3s are 14 gauge. So those will be bundled together. That's where you find that. But Aaron, I'm going to pull up the detail for the lap if you want to kind of explain the difference in laps.
There's, I guess it just depends on how the building is engineered, but this lap is from center of rafter left is 1 foot 1¾ and the right is 1 foot 1¾ so you have a total of 2 foot 2.5 inches of lap. And when he brings up that detail, that is important, the lap, because it will tell you how many bolts you need to put in that connection. A lot of people just assume that since there's 4 holes, we do 4 bolts, but that is not the case.
Jared, what detail am I looking for here?
I think it was SD 50.
Yeah, that one's going to be more accurate.
SD 50.
More specific.
That'd be 2 foot lap.
Yeah, there we go.
Right. Mm-hmm. And what that's calling out is from the center. We pause this. From the center of the column to the edge. If I can turn this around. So from this edge here to this edge here in this detail, it's 2 foot 1 3/4. On the plans that we were looking at, that lap is 1 foot 1 3/4. This isn't really been as much of a problem as long as you have the right part in the as long as you have the right part. Let me go back to the other set of plans here. But a lot of companies do gang punching, or what we call gang punching. And what that is where the girt just looks like Swiss cheese. There's holes everywhere. And so they only have like 1 or 2 standard punches that they use because it works in every scenario. And with that, it can be difficult if you're not, you could throw the girt up there, the Purlin up there, and the frame is twisted, but it happens to line up with holes and you just sink the bolts, right? You want to check that. You want to check that lap. With the Great Western Building System, we're only punching the holes that are needed. So it's pretty obvious, which holes you're putting in, but we do still call that out on that lap. I don't know if that made any sense, or is I just mumbling? It's been like
I've actually never seen gang punching.
Right.
I know that it exists. I've just because I'm only familiar with our own building systems. Yeah. I've actually never seen that in the field yet.
It's like an MBCI A or B punch. SBS has the same. I mean, almost all manufacturers do it that way because it's just easier in detailing. But a lot of that detailing is subbed out overseas. Here we do everything in house, so we only put in the holes that are needed. And it just visually, it looks a lot better when you're inside of the building. You ever walk into a metal building, you're like, geez, why did they drill so many holes in this? Right? Like, is that as strong? It is as strong, but it doesn't look good, and it's a little bit more difficult in the field, I think.
Yeah, I mean, anything that prevents errors in the field, it's pretty helpful. Not everybody who's putting up these buildings has any experience at all. So, you don't want to introduce an opportunity to make a mistake when it's not necessary.
Okay. Well, we're getting close to an hour and a half here. I think, the purpose of the episode was really just to show, how to use the set of plans when you're in the field and where to find the information. So,
yep.
As always, if you have questions,
we got that.
Yep. Call us, and everything is called out, and it's important to follow the plan. It just saves hassle later. One day we will come back and do the trim details. Oh, that's something I was going to mention. So an SD detail, these SD call outs, Jared calls them standard details. I call them structural details. That's really for like the frame of the building system. Details that start with the letter T, TD, I call a trim detail because that's what we're doing. We're sheeting or flashing the building. It's not so much of a structural connection. It's more of putting the walls and roof on. That's what I got today, guys. What do you guys have?
We could probably do a week worth of going over stuff on plans.
All right.
This is a dense episode.
Yeah. And Justin, when you break this, when you edit this, I don't think that you need to do any addition here. Let me dump this. I don't think that you need to do any additions for showing drawings or whatever. But if you could, what am I thinking? If you could chapterize it so that anybody that wants to see it, they can just go to that chapter. If they're like, I'm trying to understand
I think that's going to be very important. Chapters are going to be key for anyone going through over an hour and a half or whatever, however long we've gone now. That's going to be super helpful. Even for me coming back,
if you have questions, the Metal Building Show at GW Buildings. The four of us receive those emails. We've gotten some there, so we appreciate the questions that have come in. Or the Discord page. Go to our website, go down to the bottom. Please join Discord. You can go right into general topics, steel market updates. If you have a suggestion for an episode or something, it's a great place to put it. There's a lot of team members that are on the Discord. Generally, I'm answering those questions. And of course, comment in the YouTube video, because we do read those comments. We'll generally try to respond to it and answer the question right there. But then if it's important enough, we'll bring it up in an episode. For previous episodes, you can go to the website under resources. It's called the Metal Building Show. So you can see past episodes and a description of the episode and find the information that you want. This is going to be the fourth one up there. So hopefully we'll be adding a lot more content. We'll figure out what we're going to do next week. I'll post that on Discord, on the Discord channel. And obviously we'll talk about it internally, but I'm thinking.
Wait, I got a message earlier that we're having some issues with the live chat. People keep trying to message and it's not coming through. So I just want to apologize to anybody that's affecting. It's a YouTube problem. Nothing to do with us. I don't know why that's breaking down for you. I'm sorry. It's a bummer for some of you.
Well, let's get out of here. I got a bunch of work to do. So Aaron, thank you. Jared, thanks.
Thank you guys.
We will see you in a week.
Indeed.
Until next time.
Take care, guys.